So, okay, well, I will go ahead and get those graded and back to you tomorrow so we can go ahead and take a look at it. Just a couple of things very quickly, and I had, unless I misplaced someplace, I'd written down everything so I wouldn't forget something to tell you folks. Okay. All right, well, it looks like we're going to wing it. Okay, so Monday morning is the deadline if anybody is looking to retake that exam from last week. I would encourage a lot of people to go ahead and take a look at that. In fact, what I did to go ahead and help you out, if you take a look at our newest posting on the website, because it was a CFA, you don't have a copy of that. I did go ahead and post all of the problems with the key. If you'd like to go ahead and take a look at that, maybe come on in and ask me something about it if you need to. Okay, but you have until Monday morning if you're looking to retake. Remember the Vertex homework that I gave you yesterday, that's going to be due tomorrow. Okay, in fact, I've got a whole listing of all the upcoming assignments on the board. This same information is already on the website. Now, you haven't received a lot of those yet, but I just wanted to kind of give you a heads up as to what's going to be happening as we push into the next couple of weeks, because we got to get to a certain point before Thanksgiving. Okay, so we'll have the Vertex quiz coming up on Monday. I believe that's in our Google posting here. And I did pass this out yesterday. Now, it's not completed. Starting tomorrow for the next couple of days, we're going to be hitting factoring really hard again. So it's definitely a skill that's going to be very useful to you. So if you're still struggling, I would encourage you to go ahead and practice this. Take a look at some of those problems. Come on in if you're having trouble. Okay, but are there any questions? Okay, let's see. Yesterday we were talking about transformations, and we kind of led that into the vertex form. So if we're adding or subtracting, that is a shift. Now remember, if we're shifting horizontally, we take the what? Starts with the O. The opposite direction. So x plus shifts me left, x minus shifts me right. Remember, parentheses, let me know that that was horizontal. If you're multiplying or dividing, that is a dilation. So vertically, we're going to be stretching or shrinking it, and then the negative is a reflection. So here is our vertex form. What we've been looking at recently is standard form, ax squared plus bx plus c. So vertex form is a times x minus h squared plus k, where your vertex is hk. Again, we're taking the opposite of that h value. Okay. And after we got through the transformations, everybody seemed to be doing pretty well. Let's just go ahead and pick it right back up. We are currently on number 9. So x squared minus 4. Now, maybe this is one of those ones where you can just look at it as far as the transformations go. It's subtracting, so that's definitely a shift. But what direction? It would be down. Now, I know it's not horizontally because there's no what? There's no parentheses, okay? So there's no opposite, nothing like that to be taken here. Now, remember, our form is this right here, a times x minus h squared plus k. So you might be looking at that and thinking, that doesn't look like vertex form. Well, what if I wrote it like this? Because what's x minus 0? It's still x, right? It simplifies down to x squared minus 4. But see, now you have an actual h and your k. So can anybody tell me what the vertex of this function is? Okay. Well, what is h? 0. Neither positive nor negative. And am I going to put 4 or negative 4? Negative 4. Remember, I don't take the opposite of k. I leave k as is. Okay. Now, we want to go ahead and fill in the table so we can kind of get an idea of what's happening here. So, from your x value, we're going to count up and down by 1. So, 1, 2, 3, and then negative 1, negative 2, negative 3. And the same idea that you just saw on your quiz is still playing into this. You should see the symmetry in your y values. Okay, so we'll go ahead and plug in a few of these just, for practice. Let's say 1. Okay. So I'm going to plug it in here. Remember, every x, that's what we're plugging in. So f of 1, that indicates what value I'm currently going to substitute in. So this would be 1 minus 0 squared minus 4. Okay. Well, 1 squared is 1. What's 1 minus 4? Negative 3. Now, what else should give me a y value of negative 3 if I plug it in? There you go. Okay, let's go ahead and plug in one more of these. How about 2? F of 2. So that would be 2 minus 0 squared. Now, I'm going off this so that we can see vertex form, but if you just want to go ahead and plug it in and say 2 squared minus 4, I mean, that's going to work out the same way. Okay, so 2 squared is 4 minus 4. Looks like I'm going to get what? 0. Okay, so negative 2 would also give me 0. And just to save ourselves a little bit of time, if I plugged in negative 3, that would give me a 5. And 3 would give me a 5 as well. That's a horrible 5, but I'm saying it's a 5, so it's good. Okay, well, let's go ahead and sketch this thing. So our y-intercept is the same as my vertex. So 1, 2, 3, negative 4. So we have negative 1, negative 3. We got 1, negative 3. We got negative 2, 0. We have 2, 0. And, I mean, we got a couple more points, but we have definitely more than what we need to see this graph right here. So a couple of things what we've been doing from the previous lesson, okay? Does this vertex contain a maximum or a minimum? Okay, a minimum, because it opens up. And one other thing, what's the axis of symmetry? Okay, what value do I use from the vertex? The x value. Remember, that's what splits it right down the middle. Okay. All right, well, let's take a look at another one here. Okay, number 10, f of x equals a negative x plus 5 squared minus 1. Okay, take a few seconds, think about what we discussed just now and yesterday. Okay, go ahead and write down that vertex for me. Okay. This is what's nice about vertex form. You don't need the opposite of b divided by 2a. Okay, the only work to do is to look at your function and see what the vertex is. Okay, so let's see here. Oliver, can you help me out? What's the vertex from number 10? 5, negative 1, you're very close. Okay, Joseph? Negative 5, negative 1. So you're correct. This is the h, this is my k, but it's only the h that we have to take the opposite of. Okay. So negative 5 and a negative 1. Everybody okay with that? Remember, because we take the opposite direction when we shift horizontally. Okay. Well, let's see what we got here. I'm going to go ahead and count up. So this would be a negative 4, negative 3, negative 2, and then negative 6, negative 7, negative 8. All right. So like I said, we're just go ahead and we'll do a couple of these because I think we're starting to get the idea. Let's plug in negative 4. So f of negative 4. So that's going to be negative. X plus 5 is a negative 4 plus 5 squared minus 1. Okay, now remember your order of operations. We've got to take care of the parentheses and the square before we look at the negative in front. So kind of forget that's there right now. Negative 4 plus 1, 5. I almost gave it away. Negative 4 plus 5 is a 1. Okay, now we know 1 squared is 1. Now we're going to apply the negative. So that's negative 1 minus 1. What am I looking at? Negative, ooh, not 0. Negative 2. So what other value would give me negative 2 if I plugged it in? Yeah, negative 6. Okay. And see, once I find half the table, I already have the other half. I don't have to do that work. Okay. Let's go ahead and do one more of these. What do you want to plug in? Negative 3 or negative 2? Negative 2. So f of negative 2. So same thing. This is negative. X plus 5 is a negative 2 plus 5 squared, and then minus 1. Okay. So let's run through this. I need a negative 2 plus 5. Okay, so that is a 3. 3 squared is 9. Now I apply the negative. So that's a negative 9 minus 1. What am I looking at? Negative 10. So if negative 2 gives me negative 10, negative 8 would give me the exact same thing. And then you can go ahead and check this, at some point. If you were to plug in negative 7, that would give you a negative 5, as would that negative 3. Okay. And now let's just go ahead and plot those points. Are there any questions so far? Anybody having a hard time? Okay. Well, let's see here. Negative 5, negative 1. 1, 2, 3, 4, negative 5, negative 1. So there's my vertex. Negative 4, negative 2, negative 3, negative 5. Okay, then we got negative 6, negative 2, negative 7, negative 5. Okay, so definitely enough points to know what this looks like. Now, there's one other thing I want to go ahead and throw on here. We've talked about it before. Starting tomorrow, we're going to be looking for those x-intercepts, okay? But let's say I want to know the location of the y-intercept. Remember, the y-intercept is always found when x is what? When x is 0. Okay, and you'll notice I don't have that readily available in my table like the previous problems did. So let's go ahead and plug in 0 here. So this would be negative 0 plus 5 squared minus 1. This will allow me to do that. Okay, so 5 squared, 25, times the negative, negative 25, minus 1. So that y-intercept would be negative 26. Angel. Oh, yes. Okay. All right. So see, finding the y-intercept is super easy. Unfortunately, it's not like standard. It's not the constant. You do have to do a little bit of algebra to find it with vertex form. Okay. Cool, cool, cool. How are we doing? Everybody's okay? All right, now let's go ahead and start skipping around a little bit. Numbers 12 and 13, does anybody remember what we call those? Piecewise functions. Okay, so we're only looking for pieces of the graphs that we're given. So I've already shown you one yesterday. At some point, we're going to go ahead and get into those in a lot more detail. But for right now, we kind of have an idea of what they are, at least that they exist. So we're going to go ahead and skip them. Let's come on down to these last ones here. And if we have time, we'll go back up to one of the previous ones. But I think we're getting close. Okay, so what's the difference between numbers 14 and 15 and what we've done already? Yeah, they're inequalities. So this is where I decide if my curve is solid or dashed, and I'm going to decide where to shade. Okay, everything else is going to be the same. All right, so how about this? Let's do number 15. F of x is greater than or equal to 4 times x plus 1 squared minus 7. So based on what we said yesterday, the 4, this would stretch vertically by a factor of 4. The minus 7, it would shift down 7 units. What about that plus 1? Is it going to shift left 1 or right 1? Why left? It says plus 1. Remember, horizontally, you've got to take the opposite. Okay? What's my vertex? Okay, here's my h, the k. Remember, the h you take the opposite of. So it is negative 1, negative 7. Okay. And let's go ahead and count. So that would be 0, 1, 2, negative 2, negative 3, negative 4. We're always doing the same thing. Now this one, we're actually going to know what the y-intercept is. Let's start with 0. So 4 times 0 plus 1 squared minus 7. Okay, so what's a 1 squared? Okay, 1 times 4 minus 7. Okay, negative 3. Okay. So what else would give me a negative 3? Negative 2. Okay. So this portion is exactly the same. Okay, if I were to plug in a negative 3, I'm going to get a 9. So that means if I plugged in a 1, I would also get a 9. Okay. What Would anybody like to see one of those? Okay. If I plug in a -4, I'm going to get a 29. So I'm also going to get a 29 if I plug in a 2. Now, normally at this point, we'd go ahead and draw the curve and we'd be done with it. Okay. But this is where we have to make our decision. Is this thing opening up or down? It's opening up. How do I know that? Because A is what? A is still positive. Okay. So here's the thing. Remember, you're going to draw a solid curve if we have equality. But if you don't have equality, that's when you're going to draw a dashed curve. Okay. So this one has equality, so it's definitely going to be a solid curve. Let's see here, -1, -7, 1, 2, 3, 4, 5, 6. So there's my vertex right there. 0, -3, -2, -3. Then we have a -3, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be a little off the grid, but that's okay. So we're going to have something that looks like this. The only step remaining, am I going to have shading above or shading below? Okay. Remember, compare your y to your inequality. If it says y is greater than, or equal to, you're going to shade above. If it says y is less than, or equal to, you're going to shade below. Okay. So y here is what? Greater than. So where would above be for this curve? It'd be inside of it. There we go. Okay. How are we doing with vertex form? Okay. Remember, the homework is due tomorrow. Okay. We'll have a quiz over this on Monday. Okay. All right. And that was just enough time. We got less than 2 minutes. Perfect, perfect. Okay.